Okay, so now that we've taken a look at slopes and rate of change, we're going to go back into our characteristics lesson 6 and look at how this applies to parallel and perpendicular lines. So when we're talking about transformations, in earlier mathematics courses we started transformations, a translation, a reflection, and a rotation. In order to investigate parallel and perpendicular lines, we'll review translations and rotations. So on the grid, show the image of the point A at 2 and 5. So I'm going to go right 2, I'm going to go up 5, and I'm going to call this point A. In each case, we're going to write the coordinates of the image after a transformation. So it wants us to translate this 3 units to the right and 2 units up. So I'm going to go from point A, right 3, and up 2, and I'm going to call that B. This is going to increase the x value by 3, so that's going to become 5, and it's going to increase the y value by 2, so that's going to become 7. If I rotate 90 degrees clockwise of the rotation about the origin, then that means that I'm going to go 90 degrees from here and I'm going to get point C if I wrote 90 degrees. And C is going to be at the point of 5 and negative 2. If I rotate 90 degrees counterclockwise from the origin, I'm going to rotate and get 90 degrees in this direction, and I'm going to get point D. In this case, point D is going to be at negative 5 and 2. If I'm taking a look at investigating parallel line segments, on the grid below, the image of a line segment AB after the following transformations. So I'm going to do a translation of 4 units to the right and 1 unit down to form line segment C. So I'm going to go right by 4, 1, 2, 3, 4, and down 1. I'm going to do the same thing for B. Go right 4, 1, 2, 3, 4, and down 1. And because it's a line segment, I'm going to connect this again and say that that is going to become CD. For the next one, it says we want to go 3 units to the left and 6 units up for EF. So I'm going to go left 1, 2, 3, and up 1, 2, 3, 4, 5, and 6. And do the same thing for B. Left 3 and up 1, 2, 3, 4, 5, 6. And then connect those 2 points, and I'm going to call that EF. For the last one, it wants us to just do 3 units down. So I'm going to do A 3 units down, B 3 units down, and connect them. And that's going to be GH. If I'm calculating the slope of each of these line segments, well, the slope of A to B is to get from point A to point B, I had to go down by 3 and right by 6, which means that the slope of AB is going to be negative 3 over 6 or negative 1 over 2. For CD, that one is also down 3 right 6. The slope of CD is going to be negative 3 over 6 or negative 1 over 2. Slope of EF, well, to get from E to F, I'm going to go down 3 right 6. And it's going to be negative 1 over 2. And I'm sure you already see the pattern for the slope of GH. is going to be negative 3 over 6 or negative 1 over 2. If the 4 line segments are parallel and it wants us to make a conjecture or an educated guess about the slopes of parallel lines have the same slope. Stands to reason. Okay. If I'm looking at perpendicular line segments, so on the grid, we're going to, like we did in the beginning, start by plotting the point of 5 and 2. And we're going to call this point A. We're going to draw a line connecting that to the origin. So we're going to draw and connect A to this point. I'm going to rotate the line 90-degree angles clockwise about the origin to get to the new point. And that point is going to be down here when I rotate it and give myself a 90-degree angle. If I'm finding the slopes of the 2 perpendicular lines, so let's call this point C again like we did in the first case. If I find the slopes of the 2 perpendicular lines and then multiply them together, well, if I take a look for the first one, then I've gone up 5 and right 2. So the slope of the origin to A is going to be 5 over 2. For the second one, the origin to C, I had to go down 2 and right 5. So the slope of the origin to C is going to be negative 2 over 5. If I multiply these together, 5 over 2 times negative 2 over 5 is going to give me negative 10 over 10, or negative 1. If I'm going to repeat the process for a point called B at negative 6 and 1, then I'm going to start at that negative 6, up 1, and there's a point of B. I connect it to the origin, and then it wanted us to rotate it 90 degrees clockwise, so I'm going to have a second point that exists up here, and for right now I'm just going to call that D. The slope of the origin to B is going to be, to get to that point, I have to go down 1 and right 6. The slope of the origin to D is I have to go up 6 and right 1. Negative 1 over 6 times 6 over 1 is going to give me negative 6 over 6, or just negative 1. If I'm making a conjecture about the slopes of perpendicular line segments, then there's 2 things I can state about this. One is the product or multiplication of perpendicular line segments will equal negative 1. The second statement is that perpendicular line segments are negative reciprocals. Meaning that if one is positive, the other one has to be negative, and then I take the numerator and it becomes the denominator, denominator becomes the numerator. So if I had positive 5 over 3, then the other one would be negative 3 over 5. Or as we can see with the cases we had, positive 5 over 2 and negative 2 over 5. Negative 1 over 6 and positive 6 over 1. So if we take that and apply it towards part D, complete the following to prove the conjecture. Under a rotation of 9 degrees clockwise about the origin, if P is AB and Q is B and negative A, how is this going to work? Well, if I have B minus 0 divided by A minus 0, because the origin is just 0.00, that's just going to be B over A. If I have negative A minus 0 over B minus 0, that's going to be negative A over B. If I have B over A multiplied by negative A over B, that's going to be negative AB divided by AB. Well, AB divided by AB is just going to be 1. And because one of them was negative, I'm going to wind up with that negative 1, which proves that first statement that we made as well.